going to begin a very interesting topic. Today, we're talking about an introduction to statistics. Let's get started. All right, for the introduction to statistics, let's first define what exactly statistics is. So, statistics is the science of collecting, organizing, analyzing, and interpreting data. It's all about data. Well, first you got to collect data. Data just doesn't appear. You got to collect it somehow. Maybe you do a survey and get data that way. Maybe you perform some experiments and you measure and record data as you go along. Once you have the data, well then what do you do with it? Well, we organize it. Put it in order maybe from least to greatest. That's a common thing to do at the start. Maybe you'll put them in a table. Maybe you'll make a graph. Well, then you analyze it. What is the data telling us? We do things like find the mean, median, mode, or range to kind of get a sense of what the data is all about. And then we interpret that data. What does it tell us? Now that we know and have all this data and have tried to analyze it somehow, how does that help answer whatever questions we were looking for answers for? Okay, that's what statistics is all about. It's all about collecting that data and using it to help answer a question. So statistics is all about answering a question. Well, first, what exactly is a good statistical question? Well, a statistical question is where you expect to get a variety of answers. That's really big. A variety of answers, a whole range of answers. You're not expecting just a couple different options, right? And you are interested in the distribution and tendency of those answers. Now, one more thing I want to add about statistical questions. Don't get confused from a survey question and a statistical question. For example, if your statistical question was, how much do sixth graders weigh? Well, that's your statistical question. But when you do the survey, you're not going to ask people, how much do sixth graders weigh? You're going to say, how much do you weigh? And you go to the next person, how much do you weigh? And all the sixth graders you're going to survey, you ask them, how much do you weigh? That would not be a statistical question, but it's going to help us get data to answer the statistical question. So with that, let's get to our first example. Okay, example one. Let's say your science teacher asks you to do an experiment about mice. And she asks, what is the weight of a mouse? Okay. Well, first, is this a statistical question? And if so, explain. Now, if you remember from the definition, statistical questions should be giving us a variety of answers. They should be able to show us a distribution and a tendency. So we have to think, well, this question, if I'm doing an experiment with mice, is it going to give me a variety of answers? And the answer is yes, it will. Because you can't expect all mice to weigh the same. They're going to be different, just like humans are going to weigh different amounts. Same with mice. So our answer, yes, because you would expect the weight of mice to vary. Let's try part B. Okay, part B. So we weighed a whole bunch of mice and we collected that data and have it in this little table over here. Now what we're going to do is display that data in a dot plot. So it looks kind of confusing. It's hard to tell anything about the data, right? We've already done that first step, collecting the data. Now we're going to organize it, and we're going to make a dot plot. And then after the dot plot's made, identify any clusters, peaks, or gaps. And we'll talk about what those mean in a second. But first, the dot plot. A dot plot is basically, you have a number line. It could be horizontal or vertical. And then you use dots to show where the different data values are. It's kind of like a little bit like a bar graph, except with dots instead of bars. So we're going to start with a number line. Well, if I look at my data, I can see that the least value is 18 grams, and the greatest was 28 grams. So that's where I'm going to start on my dot plot. Okay, so I have my number line done for my dot plot all the way from 18 to 28. I need to label what these values mean. So these were all weights. So I'm going to label that over here to the side. weight, and that was in grams. Really important to label. Don't forget that, or else nobody's going to know what those values represent. And then we just look at the data and put dots. So at 18, how many mice weighed 18 grams? Well, if I look at my data, I can count 2. So I put 1, 2. Just 2 dots right above that number 18. And I keep going. So 19, if I look, there were 3. So I'm going to do 1, 2, 3, like that. And we'll keep going. At this point, you'll notice there were no 24s, no 25s, no 26s, so I'm going to put nothing there. And then I get to 27 and keep going, so there are 2 of those. And then finally, 128. One good thing to do before you're finished is just double check to make sure you counted all of the data values. So just count your dots and make sure it matches the values over there. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20. And if I look at that little chart, I have 20 values there, so I'm happy with that. Now, dot plot is done. Let's go to the next part. Identify any clusters, peaks, or gaps. Well, let's look at the clusters. First, a cluster is where a lot of data values are kind of bunched together. So if you look over here, you'll notice, well, it looks like there's a whole bunch of data values right there. You're just going to pick kind of what's in the middle where they kind of all seem to kind of be drawn to. So that would be 20. So that's a cluster. You might be asking, is it possible to have 2 clusters? Sure. If you've got a big bunch here and another big bunch here, it's possible to have more than 1 cluster. That's okay. Peaks. Well, hopefully you can kind of guess what that is. That's just, are there any things where it's the tallest? So right here, again, 20, there is a peak at 20. And same thing, it's possible to have more than 1 peak. If, for example, 21 also went up to 6, then we would say there's a peak at 20 and 21. But as of right now, there's only 1 peak because that is the tallest. And finally, gaps. Hopefully that's obvious, again, what that is, where there's spaces in between the data values, and that obviously is right here. So there is a gap between 23 and 27. Okay. So that's just kind of helping to explain our data a little bit more. Okay, and finally part C, use a distribution to answer what is the weight of a mouse, our original statistical question. Well, looking at that data, looking at our dot plot and seeing those clusters and the peaks, we can say that most mice weigh about 20 grams. Right? Our cluster was around 20, our peak was at 20, so that's how we would answer that question. Here's one to try on your own. All right, example 2. The dot plot shows the heights of 6th graders in my math class. So here is the dot plot. You can see these are all heights in centimeters, not inches. And part A says, how many students are in my class? Well, if you remember, all of these dots represent a data value. So in this case, these dots represent 1 student's height. So to figure out how many students, I just count the dots. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there are 22 students in my class. Okay, let's try part B. Okay, part B. How can you collect these data? Well, to figure out heights, we're probably going to use a measuring tape, right? And make sure that you're measuring in centimeters, right? Because that's what the data was. Let's try part C. Okay, finally part C. Write a statistical question you can answer using the dot plot and then answer that question. So we're writing a statistical question. It has to be about the dot plot. Remember, this was about height of students in my class, so maybe our question could be, How tall are 6th graders in Mr. Jacobson's math class? That is a question that we could answer using this dot plot. So that's great. There's our statistical question, and let's answer it. Well, how tall are most 6th graders in my math class? If you look, we have two peaks right here. There's 56 and 57. By the way, you may have noticed I didn't label every single dash, but if you notice, I'm going by the same amount. So 152, that would be 153, 154, 55, 56, 157, 158. That's fine. You can do it that way. Just be consistent. So we've got a peaks here at 156 and 157. That's also kind of where we have a cluster. So we would say most of the students are, about 156 centimeters, probably, are about 156 centimeters tall. Hopefully you can see all of that. That's it for example 2. Here's one to try on your own. As always, thank you so much for watching, and if you like this video, please subscribe.